On the off chance that we take out the lines, the most entrancing star I perceive is the one that could be shocking in our sky. It is this unsavory little animal, Betelgeuse, often referred to as Betelgeuse, a red giant star. If you were to place it where the Sun is, it would extend out to the orbit of Jupiter. This colossal, extremely whimsical star will detonate at some point. However, it's not as clear as it seems. In the universe, thrilling events like the most gloriously dreaded stellar explosions could shake all that we see, and even what we don't see, to its core. Betelgeuse has been viewed as a significant celestial sign, a red giant star that is several times more massive than our Sun. Brian Cox and other space researchers believe it could go supernova at any moment. People are naturally fascinated and a bit frightened by what might happen, especially as the James Webb Space Telescope is capturing stunning photos of the star. When exactly will Betelgeuse become a supernova, and how massive will the impact be on Earth? Let us investigate. This star, in the majestic constellation Orion, shines so brightly that even ancient civilizations observed its significance. The eminent star Betelgeuse is located on the eastern shoulder of the constellation and is the second largest star in that region. Its name derives from the phrase, the giant's shoulder. It is arguably one of the most magnificent stars in the night sky. On top of being exceptionally bright, the star is also an odd shade of red, which, as we will see, signals trouble. Humanity has been aware of Betelgeuse for a long time. A Greek scientist named Ptolemy documented it centuries ago. Back then, people's understanding of stars was primarily based on their color. Ptolemy observed that Betelgeuse was orange. Scientists have focused on the star more closely in recent years and now have a good understanding of what makes it so unusually bright. One notable feature is that the star's brightness fluctuates significantly, with an apparent magnitude of 0.6. Betelgeuse is a variable star, meaning its brightness changes over time. However, in 2019, researchers noticed something curious. Betelgeuse became significantly dimmer, darkening to a magnitude of around 1.6. Scientists quickly began investigating why this extraordinary behavior was occurring in the 10th brightest star in the sky. Experts soon made a startling discovery. Betelgeuse had been emitting odd signals, leading scientists to speculate that it might go supernova suddenly. Brian Cox, a prominent physicist, declared that Betelgeuse resembles a ticking delayed bomb. This statement carries weight, as Cox is a professor of particle physics at the University of Manchester and a respected science communicator. To support these observations, the James Webb Space Telescope provided crucial evidence. But what odd signals was Betelgeuse emitting that garnered so much attention? With new data from astronomical studies, the star has been classified as a supernova candidate. However, researchers remain uncertain about the timeline. Betelgeuse's enormous mass, several times that of the Sun, is one factor supporting this classification. Typically, stars with such mass are prime candidates for supernovae. Using advanced instruments like the James Webb Space Telescope and the Laser Interferometer Gravitational Wave Observatory, researchers closely examined Betelgeuse. In 2019, the star emitted unusual light waves, and scientists also noted significant dimming. This phenomenon, called the Great Dimming, occurred in late 2019 and early 2020. During this time, Betelgeuse's brightness dropped to unprecedented levels. The dimming raised concerns about an imminent explosion. However, the star later brightened, becoming 150% more luminous than usual. Astrophysicist Andrea Dupree, from the Harvard-Smithsonian Center for Astrophysics, stated that Betelgeuse is now the 7th brightest star in the sky. Scientists observed a red glow in the southern hemisphere, sparking various theories about the cause of this phenomenon. The red glow is attributed to Betelgeuse being a red supergiant star, a phase marking the end of a star's life. The surface temperature of Betelgeuse is around 3,500 Kelvin, much cooler than the Sun's outer layer, which is about 5,500 Kelvin. This lower temperature means Betelgeuse emits less energy per unit of surface area despite its enormous size. Brian Cox questions whether the dimming indicates that Betelgeuse will soon go supernova. As a red supergiant, Betelgeuse is nearing the end of its life. A dying star naturally dims over time. However, Betelgeuse's recent irregular behavior has intensified scientific interest. Numerous telescopes are now monitoring its activity closely. The James Webb Space Telescope has provided key insights into Betelgeuse's surface mass ejection during the Great Dimming. Researchers determined that the mass ejection was 400 billion times larger than a typical solar mass ejection. The telescope can also observe frequencies invisible to the human eye, offering a detailed view of the star's behavior. Despite these observations, researchers remain unsure of when Betelgeuse will explode. If it does, it will be the first supernova witnessed by humans since Johannes Kepler's observation in 1604. While astronomers continue to study Betelgeuse's behavior, its ultimate fate remains a captivating mystery. Understanding Betelgeuse's death could reveal the complex processes involved in stellar evolution and supernovae, which play a crucial role in forming heavy elements like gold, silver, and iron. These elements, forged in the extreme conditions of supernovae, contribute to the birth of new stars, planets, and even life itself. If Betelgeuse explodes, the event will create an astonishing spectacle in our sky. Astronomers estimate that the supernova could shine as brightly as the full moon and remain visible for weeks or even months. It will release enormous amounts of energy, including visible light and other forms of electromagnetic radiation. However, experts reassure us that Betelgeuse is far enough away, approximately 642.5 light-years from Earth, that the explosion would not pose a direct threat to our planet. Instead, the supernova would provide a rare opportunity to study such an event in unprecedented detail. Modern telescopes and instruments, including the James Webb Space Telescope, are far more advanced than those available during the last observed supernova in 1604. By capturing and analyzing data from Betelgeuse's explosion, astronomers could unlock new insights into the physics of massive stellar deaths, the distribution of heavy elements, and the role of supernovae in shaping galaxies. Meanwhile, scientists are particularly focused on Betelgeuse's role as a precursor to other stellar phenomena. As the star nears the end of its life, it sheds enormous amounts of material into space. These expelled layers could eventually form the building blocks for new stars and planetary systems. Understanding how this material interacts with the surrounding environment could help scientists better comprehend how elements are recycled in the universe. For now, Betelgeuse continues to captivate astronomers and stargazers alike. Its reddish glow and periodic changes serve as a reminder of the universe's vastness and the delicate balance governing the lives of stars. Whether it explodes tomorrow, in a decade, or in 100,000 years, Betelgeuse's story is far from over. Scientists remain committed to unraveling the mysteries of this remarkable star. Through their efforts, Betelgeuse may one day provide answers to some of the most profound questions about the universe, its origins and its ultimate fate. As telescopes and observational tools become increasingly sophisticated, the story of Betelgeuse only deepens. One of the most intriguing aspects of this red supergiant is how it challenges our current understanding of stellar evolution. Betelgeuse provides an extraordinary case study, showing that even the most well-studied stars can exhibit unexpected behaviors. This unpredictability is a reminder that the universe is far more dynamic and mysterious than we often assume. In recent years, scientists have focused on Betelgeuse's surface dynamics, particularly the presence of massive convection cells. These cells, which transport heat from the star's core to its outer layers, are believed to play a role in the star's irregular brightness. However, the precise relationship between these convection cells, mass ejections, and the Great Dimming remains a topic of intense study. The James Webb Space Telescope's ability to capture infrared light has proven invaluable, allowing researchers to peer through the dust clouds and gain a clearer view of Betelgeuse's surface activity. Theories about the Great Dimming continue to evolve. Some scientists speculate that it may have been caused by an enormous plume of gas and dust expelled from the star, which then cooled and condensed into a thick cloud that temporarily obscured Betelgeuse's light. Others suggest that internal processes within the star, such as fluctuations in nuclear fusion rates, could also have contributed. Regardless of the cause, the event has sparked a wave of research into the late stages of stellar evolution. One of the most exciting possibilities is that Betelgeuse may serve as a natural laboratory for studying the processes that lead up to a supernova. Observing its behavior in real time gives astronomers an unprecedented opportunity to refine their models of how massive stars die. These models are crucial for understanding the life cycles of stars, the formation of heavy elements, and the broader mechanics of the universe. For stargazers and amateur astronomers, Betelgeuse has become a celestial celebrity. Its prominent position in the night sky makes it a favorite target for observation. The star's dramatic fluctuations in brightness, combined with the possibility of an impending supernova, have captured the public's imagination. Educational programs and outreach efforts have sprung up around the world, using Betelgeuse as a gateway to spark interest in astronomy and science. Despite the excitement surrounding Betelgeuse, scientists caution that the timeline for a potential supernova remains uncertain. While it could happen within our lifetime, it is just as likely that the star will continue its unpredictable behavior for thousands, or even hundreds of thousands, of years. For now, Betelgeuse stands as a symbol of both the power and the mystery of the cosmos, reminding us of the delicate balance that governs the lives of stars. As technology advances and our understanding of the universe deepens, Betelgeuse will undoubtedly remain at the forefront of astronomical research. Its eventual explosion, whenever it occurs, will not only be a spectacular event for humanity to witness but also a milestone in our quest to comprehend the universe. Until that day arrives, scientists, stargazers, and dreamers alike will continue to marvel at this extraordinary red giant, eagerly awaiting the moment when Betelgeuse reveals the next chapter of its cosmic story. Betelgeuse, with all its unpredictability, remains a cosmic enigma and a beacon of curiosity for astronomers around the world. As we delve deeper into the mysteries of this red supergiant, its significance transcends the astronomical community, resonating with anyone fascinated by the universe's vastness and complexity. Preparing for the inevitable. When Betelgeuse eventually goes supernova, it will mark one of the most significant celestial events in human history. The explosion is expected to release an immense amount of energy, equivalent to the combined power of billions of suns, and create a spectacular light show visible even during the day. This event will not only be a visual marvel but also a scientific boon, providing a once-in-a-lifetime opportunity to study the physics of supernovae in unparalleled detail. The supernova's light curve, the way its brightness changes over time, will be meticulously analyzed to understand the star's internal mechanisms leading up to its death. Scientists will also study the blast's electromagnetic spectrum to identify the chemical elements expelled during the explosion. These observations will help refine our understanding of how supernovae enrich the universe with heavy elements that form the building blocks of planets, moons, and even life itself. Impacts on Earth and beyond. While Betelgeuse's supernova is expected to be harmless to Earth due to its distance of approximately 642.5 light-years, it will have profound effects on its immediate cosmic neighborhood. The shockwave from the explosion will compress surrounding gas and dust, potentially triggering the formation of new stars. The remnants of Betelgeuse, likely a neutron star or possibly even a black hole, will continue to influence its environment for millennia to come. For humanity, witnessing a supernova of this magnitude will be a profound reminder of the universe's power and fragility. It will serve as a stark contrast to our everyday lives, prompting philosophical and scientific reflections on our place in the cosmos. Observatories across the globe will work tirelessly to capture every detail, ensuring that the event is documented for future generations. The legacy of Betelgeuse. Even in its current state, Betelgeuse has left an indelible mark on our understanding of stellar life cycles. Its erratic behavior has challenged existing models, forcing scientists to rethink long-held assumptions about massive stars. The star.